Hello children, we are going to derive formula for force on a current carrying conductor in magnetic field. You know that moving charge in magnetic field, perpendicular magnetic field experience magnetic Lorentz force, right? Same way current is nothing but moving electrons, right? So this moving electrons in magnetic field, it will also produce force, right? So we are going to derive formula for force. First we will analyze the diagram. You can see the conductor of length L. L is the length of the conductor. In this magnetic field is acting perpendicularly inward, okay? Is perpendicular to the plane of paper and it is acting inward, so represented by cross. Now here the charge we are considering is the electron. Electron moves with the drift velocity Vd, right? Now you can see the current and the drift velocity. Current and the drift velocity are in opposite direction. This represent A represent the cross sectional area of the conductor. In this conductor, consider a small elementary length dl. Okay, this dl is the elementary length, and here we have to know the volume of this elementary length. So volume of elementary length is A into dl. You have to note it down children, later we need this. So volume of this elementary length is V is equal to A into dl, right? Now also you should know what is capital N, what is small n. Okay, capital N is the number of electrons in this part, okay, in this volume. Repeatedly I am saying we need it in later part. How many electrons are there in this volume? Capital N, n number of electrons. So what is small n? This is nothing but the number of electrons per unit volume, okay. That means in the conductor, if you consider 1 centimeter cube of this part, okay, how many electrons are there? There will be n electrons. Capital N is the number of electrons in this volume, in this elementary length of the volume V, okay. Now all these we have written here. E is the charge of electron. You have to note it down children in the description. So we will calculate force experienced by the conductor in magnetic field. So F total is equal to F1 vector plus F2 vector plus F3 vector, etc. What are this F1, F2, F3 and all? So F1 is the magnetic Lorentz force of first electron in magnetic field, okay. This is the magnetic Lorentz force of the second electron in the magnetic field. So total force is the sum of Lorentz force of individual charges, right? So total force is the sum of Lorentz force of individual charges, right? Now we will go to the derivation part children. Now already you know the relationship between current and drift velocity. I is equal to NAE into Vd. Current, number of electron per unit volume, area of cross section, charge of electron and drift velocity. Okay, relationship between current and the drift velocity. Now you know the Lorentz force experienced by an electron in magnetic field. This is the general formula. F is equal to Q into V cross B, right? Q you are replacing it as minus E, right? Q we are replacing it as minus E because here we are considering the electron. Electron has negative charge, so put minus sign here. Instead of we are writing Vd children, okay, drift velocity. So N is the number of electron per unit volume. Small n is equal to capital N by V. Capital N is the number of electron per unit volume of element dl. V is equal to A into dl. While explaining diagram I told you all these things, right? Now Lorentz force on n electrons. Lorentz force on n electrons in dl element, right? Here how many electrons are there? N electrons. So here for the n electrons you are calculating the Lorentz force. So what is Lorentz force? Df vector is equal to capital N into f small f vector. Substitute the value of n. You know that capital N is small n is capital N by V, so capital cross multiply n into V, V is ADL, right? This n value you can substitute here. So instead of n, NADL, F value already you got it here, right? F is nothing but minus E VD cross B. So F value you have written here. Bring the negative sign and you can remove the bracket, okay. Already I know, you know I is equal to NAE VD. Multiply DL on both the sides children, okay. DL multiply on both the sides and introduce negative sign. Negative sign, why do you introduce? It indicates that current and the drift velocity are in opposite direction. So negative sign indicate current and drift velocity are in opposite direction, okay. So you can replace all these by IDL, okay. IDL is this part, right? So you can replace all these by IDL cross B vector, right? So you have calculated Lorentz force only for this part. Now you are going to calculate Lorentz force for this length. Okay, for this length L you are calculating. So therefore Lorentz force on the current conductor of length L in magnetic field is, so dF you can replace it as F vector. Okay, total Lorentz force, IDL I, so for this is elementary length, this is for full length, cross B vector. Okay, so IL cross B. Okay, now magnitude, what will you get? F is equal to BIL sin theta. So F is equal to BIL sin theta. A cross B formula I have used, ILB sin theta. So I have written it as BL sin theta. Now we will discuss two cases. If the conductor is along the magnetic field, then theta is 0. What is theta, children? It is the angle between IL vector and B vector. Already you know that magnetic field is perpendicularly inward. Same way current carrying conductor is also perpendicularly inward, means theta will be 0, right? Now theta is 0 means F becomes 0. So in this case, if the conductor is along the magnetic field, F will be 0. But if the conductor is perpendicular to the magnetic field, theta is 90 degree. If you put 90 here, what will you get? Sin 90 is 1. So F is equal to BL. Force will be maximum. Right, children? Children, to find the direction of force on current carrying conductor, you can use Fleming's left hand rule. For that you have to stretch the forefinger, middle finger and the thumb of left hand mutually perpendicular to each other. You see, forefinger, middle finger and the thumb of left hand are mutually held perpendicular to each other like this. Okay. Now you should write what does each finger represent. Okay. So forefinger it will write, see, forefinger, middle finger and the thumb. Okay, wow. I have written it as M, C, F. Okay, in each finger I have represented. This is a clue, children. See, F means F represent here. Clue word is father, mother, child. Okay, father, mother, child, and this is force. This represent technically it represent force. This represent magnetic field, and this finger represent the current. Okay. Clue word is father, mother, child, and technical word representation of this finger is force on experienced by the conductor, magnetic field, and this is the current. Okay. So what does each finger represent? Forefinger represent magnetic field, middle finger represent current, and the thumb finger represent the force experienced by the conductor. Okay, children, if you apply this law to this diagram, you can see that the thumb finger it will point vertically downward. So the force on the current carrying conductor it will be downward direction. Your forefinger should be inward. The middle finger if you have to place in this direction. If you have to place the middle finger. Okay, middle finger, and B should be, that is the forefinger should be inward, then the thumb finger it will be pointing downward, which represent the force on the current carrying conductor. I hope you understood, children. This is a 5-mark question, and Fleming left hand rule alone will be a 2-mark question. Hope you understood. Thank you.